Good evening, ladies and gentlemen. Thank you for giving me a voice. I will today talk about pyrolysis combined of wheat straw, rice straw, and rubber tires. Pyrolysis will be based on article on Professor Daniel Czolkosz from Tucson and from University of Arizona and Professor Fatima from University of Professor Fatima Salsabal from University of National University of Science and Technology in Pakistan. This is shown that rice straw was chosen because rubber tire by alone is slowly decomposed. Pyrolysis is kind of decomposition, thermal, without any addition, only by means of energy, usually in form of heat. And this heat usually can be from microwave or by giving some much which is lower and much lower. In this case, professor tries to check how rice straw would shift and empower rubber tire. Rubber tire is very complex material, containing much besides rubber and polymer like isobutylene, polyisobutylene, and contain much kinds of catalyst rest and the hardening, and even some steel, which makes the rubber for entire supported and enduring strength. This causes that during your use will go long time, but after some times needs to be replaced and becomes very troublesome and harmful waste because these metals contain cadmium and heavy metals which destroy and pollute area. Therefore, this is very important to utilize quite fast. And this shows that the thermal combustion, as you studied, in the method was taken in Punjab, so in Pakistan, and was taking several wheat straw, sugar base, and cotton stock. And this shows that amount of gases product is which can be by pyrolysis can be proportional to rise of crop in the region and field collection of designated and then the pyrolysis efficiency. This is the model description. Professor Czolkosz will use this online how to prepare from the white straw mixed with milled white tires and the temperature was 550 degrees and pressure 1 bar. This shows enthalpy was calculated and give even 823 kilojoule per kilogram. First is shredding of the two parts. The parts of tire is shredded and removed from metal parts, given to 60 per 60 in initial, and then in 60 will be supplemented with 1:2 ratio of kilograms of tires to rice straw, which is initially minced, dried, and after the exhausting and leaving some part that is lignocellulose, there will be exhausting, the drying, they will be taken to the mixing and then to the pyrolysis reactor. This causes that in this case was char, which is polymer efficient polymer material like tar, and this material can be used in ethylene, in benzene, polybenzene, much polymer rest, and the other, the oil. This oil can be used in every case, even in car and in airplane. The parameter wasn't needed to much addition, only nanoparticles. The power generation was vapor steam, and this hydrogen was all which produced during this process was then returned back to give power to the rest process. So it was as much energy as is necessary, independent after some time. Therefore, was very returnable. And then we have mass energy balance, give that meeting the sufficient is allows to in Islamabad city only meet 27% such plan. So we need some another processes, another material to be containing and to be fulfilled Islamabad needs of energy. The enthalpy is at 823 of co-pyrolysis, which is enthalpies, for example, reactions after Ritztra was 450 kilojoule per kilogram, while without would be 1168, which means that Ritztra allows to make less energy for combustion and bigger digestion. This shows that the addition of lignocellulose is very important. Therefore, we need to compare different ways of lignocellulose organic and the waste from polymeric, from synthetic chemistry waste like waste tire or polymers or plastics, and change to design. And this is the trouble because for long term the waste would be changing. So we need to design to improve this design to be more suitable to the season and to change the subsidy from time to time. So this is the all for today. Thank you very much for listening to me.